Good morning, good afternoon, everybody. I'm very glad to be here today. My name is Andrea Marella, and I would like to present some innovative methodologies for the road safety and traffic roundabout analysis. I would like to ask you, thank you, all organizator for inviting me at this important convention. Traffic Lab is a traffic company. Our main business is try to test the modern technologies to provide innovative and advanced solution to our customer. In the past, also, we are usually to describe the Traffic Lab as a traffic laboratory. The main lines of business are traffic monitoring, innovative products for the smart city, and cloud platform. In this presentation, I would like to present two main innovative, from my point of view, innovative technologies for the traffic monitoring, for the traffic analysis, and for everything in the field of safety road analytics. The first one is a complex intelligence algorithms that use the computer vision to detect automatically and detail traffic analysis from aerial video. The aerial video can detect with UAV, with an aerostatic balloon, and sometimes we use also a traffic pole to detect in the detail the information from the vehicle. The specific computer vision algorithms can detect up to 7 categories, including pedestrian and cyclist, and it will soon possible to detect the e-scooter as well. And it's a very high topic because it's not easy to detect the high scooter on the road. With the aerial video and analysis, we can detect the speed, the waiting times, the region destination matrices, and other a bunch of other kind of parameters. The second innovation that we use currently from for our customer is the use of floating car data or black box. This information is very important because different from the before technique that we can analyze a medium small area. With the FCD data, we can detect and analyze the most big area. Thanks to the specific agreement, we can also provide the data in real time, and we can analyze the speed, the travel times, delay, and some other parameters. I would like to show you our case study. Our case study is a roundabout located in the suburban area in Turin area, in Ribalta di Torino, between two important rural roads. The main goal is to discover the best design implementation to fix the queue issue into different arms of existing roundabout. In order to provide an innovative traffic data monitoring system, we use a lot of innovative technique. First of all, we detect the aerial video, and we analyze with our computer vision software, as I described before. And we used also the video, in particular the photo from the camera, to detect from all area a photogrammetric survey for the detailed area in questions. In the second part, we use that floating car data for explore the pandemic generation generated by the COVID-19 pandemic, and also for validate our microscopic traffic models. And finally, we use software to simulate the microscopic traffic models to find the best solution in different kind of scenario. The first point is the photogrammetry. Thanks to the photogrammetry methodology, we covered the area in the study with about 224 aerial photo. We detect about 30 ground control point with GPS for obtain a correlation and for correct our model. And finally, we use a software to obtain a digital elevation model and above all the georeferenced automosaic. Our mean error in each coordinates are very low because we achieve about 0.01 or 2 centimeters for each coordinate. This is our narrow. This is not 0.22, but this is 0.022. So it's the centimeters, the mean error. After that, we use, and I can show you the original video. We detect, we record a video at the center of the roundabout up to about 2 hours in continuous, because our pilot can alternative fly in the center of the roundabout. Oops, sorry. The roundabout in the center of a roundabout. So we can alternative have a video and have a continuous video from the car. After that, we can analyze with our software all trajectories, obviously in post-processing mode, but now is also possible in a real-time mode. And as you can see, we can detect the vehicle type, the trajectory, and we can also detect the information about the deceleration, these shine and green line are the trajectories, and the virtual box that you can see in the detail are the information about the box. Thanks to these technologies, we can provide a large view of data, for example, a trajectory, a vehicle types, a complete metrics, speed travel time for each, for all area analyzed. After that, we can also analyze the video with heat maps, like the speeds and acceleration and deceleration, of course. We can also analyze the video with a grid and a point. For example, in this image, you can see how the queue time are increased. The red is the maximum queue time. And we also see where the vehicle are stopped and the stationary time and for each second of the video. And finally, we can analyze the video with the heat map to detect the lane of occupation. After that, we can use the FCD data, and in particular, we use the TomTom data, and we can achieve a very important data, like for every arch of a roundabout, about the toponym name, the length, but it's not important. The very important is the average and the median speed, the speed limit, the travel time, and also the sample size for each area. This is a screenshot of the TomTom Move FCD portal, and it's very important also download the data. And thanks to acquire, thanks to buy the data from the past, we can estimate the reduction from the traffic from the 19 up to the 2021. That is the period when we complete our case study. In the second part, we would like to present also the traffic model. As you can understand, we have a lot of data detected from the analyzed video, and these data are not used for the traffic demand for the OD metrics, but also we can use the acceleration or deceleration ability of the vehicle. We can detect the driver's reaction time, the following up time, the critical headway, and all these data are very important because we validate the microscopic simulation software, and in detail we can configure better the default value from, for example, the acceleration, or from the minimum gap or the headway that the microsimulator software can insert manually by the operator. In my personal opinion, when I change manually the default value from the acceleration or deceleration, the microscopic results are very different from the default data. And in this case, we are sure that the microscopic simulation are very similar to the video that we saw before. And also we can detect the safety model thanks to the computer vision algorithm. We can also detect the time to collision, TTC, the post-stack crash time, the EV braking, the conflicts image, and above all, the tangential acceleration. So we can detect and understand better how the safety model can describe it by the roundabout. And finally, we reconstructed the network in the state of the art with the scenario number 0. And currently, the roundabout have a 2-lane approach from one in the northwest approach inbound. And after that, we can validate and calibrate in detail the vehicle behavior of the people, the driver. We can also configure the travel time, and also we can model in the detail the car following model. After that, we can estimate different type of scenario. And as you can see at the scenario number 1, we tested to double the incoming lane in the south incoming inbound, because there is a very high volume and there is a very high of queue from the south inbound lane. In the scenario number 2, we insert 2 bypass in 2 main incoming lane, because in this lane very high traffic volume. So this tested also this solution. And we also tested 2 more scenarios. We try to add 1 meters the circular artery roadway, and also we add the second lane from the south incoming inbound lane. And finally, the last approach, we complete the double of all arms with 2 lanes in all approaches. Thanks to the micro simulation, we can estimate for the entire intersection, the delay time, the density, obviously the flow is remain the same, the harmonic speed, the emission, the environmental emission, for example, the mean Q and other many parameters, and the simulation results demonstrate as following: that the creation of a direct bypass lane does not bring such transport benefits to make them economically sustainable, because we don't forget the economical costs are very important for the project and from the customer, that in this case is the public administration. The only increase the circular roadway from the currently 8 meter to the 9 meter limit, 9 meter up to the maximum permitted by the law, would lead to an improvement of the entire node, but is not very important. In terms of benefit cost, in our point of view, the solution that involve increasing the circularity roadway and doubling the entrance lane in all branches, scenario number 4, results the best solution in terms of cost and for the dynamic parameters. In my point of view, I would like to conclude some results that the main of all this presentation, that is not very technical or research presentation, that I would like to demonstrate that some innovative instrument methods for the study of traffic are very really applicable in terms of cost and in terms of results. I also investigate many innovative instrumentation, and I can say that there are different solutions for different studies purpose. COVID-19 pandemic has given a strong impulse, because if we can remember my slide in COVID-19 increase traffic without FCD data and historical FC data, I cannot resolve these questions. The market purpose mature, and also most of within the plateau, in my point of view, of productivity in terms of cost and market demands. We are not worried to try the test new solution. We, in fact, call us a traffic laboratory. And the most important is to share the results as this moment. And I hope that we can discuss this slide in terms of positive or negative opinion, because in my history, the negative opinion increase the knowledge of everybody. I would like to thank you for inviting me at the presentation, and I finish my pitch, and I suppose that I'm on time.